3 strange buildings in America that will blow your mind.
America is a land of the extraordinary. Imagine, right in the heart of New York, a structure with no floors and no rooms. Just staircases spiraling upward, twisting into the sky, leading you to platforms with the stunning 360-degree view of the city.
But here's the real question. Where are these stairs even trying to go? And structurally speaking, how on earth did they manage to keep this thing standing?
Now, travel with me to Los Angeles, where a shiny metallic building looks like a sheet of the future dropped from the sky, with curves that seem to break every rule of geometry.
And just a little further, you'll find a museum with no typical windows, yet a skin that draws in light like a hidden secret, transforming the inside into a surreal architectural experience.
And once again, America is the home of the bizarre.
Hello to all viewers and supporters of the Constructive Minds YouTube channel. I'm Eleanor, which means shining light, and together with my friend Theodore, we're heading to meet Harrison and ask him about 3 of the weirdest buildings in the United States that will amaze everyone.
Eleanor, you might not believe it, but while we were preparing this video, I was so excited that I literally couldn't sleep. I just wanted to learn more and more about these 3 buildings. And trust me, the third one is the craziest of them all. Are you ready for a journey to the edge of what seems structurally and architecturally impossible? Then let's join Harrison and dive right in.
Have you ever looked at a building and just wondered, how is that even standing? You know, these structures that seem to completely defy physics. Well, that's what we're diving into today. The incredible engineering that has to happen when an architect's vision seems, well, impossible.
So here's the game plan. We're going to deconstruct 3 amazing case studies. We'll look at a giant puzzle of stairs, tackle the challenge of a massive curve, and then explore a building wrapped in a veil of light. It's going to be a fascinating look at what happens when audacious art crashes right into the laws of physics.
All right, let's get right into it. At its heart, this is really a story about the incredible tension, but also the amazing collaboration between an artist's vision and some seriously extreme engineering. Because it's right at that point when a design looks impossible that the real innovation has to kick in.
So, first up, we're going to look at this thing. It's this bronzed, seemingly endless web of staircases. It's kind of confusing to look at, right? And it's stunningly complex. It just makes you immediately ask the question, what is this even for?
Then we'll shift over to this concert hall. I mean, look at it. It's huge. Flowing metal curves make it look way more like a giant sculpture than any building you've ever seen. So how in the world do you make something that looks like that actually functional?
And for our final stop, we'll explore a museum with this totally unique facade. It's this porous, almost honeycomb-like skin that's designed to act as a veil of light. What does that even mean? We're about to find out.
Okay, let's kick things off in New York City with the vessel. The challenge here was really 2 massive problems in one. First, how you even assemble this unbelievably complex shape, and second, how do you make sure it can handle the load of thousands of people moving all over it at the exact same time?
And the first thing you have to wrap your head around is just the insane scale of this thing. We are talking about 2,500 individual steps. The stairs aren't just a part of the structure. The stairs are the structure.
And when you really look at the numbers, you start to get a sense of the engineering mountain they had to climb. You've got 154 separate flights of stairs, 80 different landings, and it's all made of this gorgeous, reflective, bronzed steel, all interconnected into this one giant flowing shape.
So the solution was kind of like putting together a giant, incredibly precise 3D puzzle. Every single piece of steel was unique. It had to be fabricated off-site, numbered, and then shipped in. Think about that. If just one piece was off by a fraction of an inch, it could throw the entire assembly into chaos. The margin for error was basically zero.
But just getting it built was only half the problem. The engineers then had to deal with something called dynamic load.
So think of it this way. The dead load is just the weight of the steel itself sitting there. But the dynamic load is the moving, vibrating, unpredictable force of thousands of people walking and climbing on it at once. It's the difference between a person just standing still on a bridge versus an entire army marching in unison across it. That moving force creates all these crazy stresses that are way harder to predict.
And this is where we see a classic unintended consequence. The engineering was a total success, right? The structure is perfectly stable. But because it was so cool, it drew massive crowds, which created this huge operational nightmare of trying to manage the flow of people, preventing traffic jams on the stairs, and just keeping everyone safe.
Okay, let's head west to Los Angeles for our next case study. The Walt Disney Concert Hall presented a totally different kind of problem. How on earth do you build these massive, flowing, sculptural curves and then somehow make it work as a world-class performance venue on the inside? Well, the key turned out to be technology borrowed from a completely different field. The engineers used a software called CATIA, which is this super sophisticated 3D modeling program that was originally created to design fighter jets. Seriously, it was the only way they could precisely map out and fabricate every single unique, curved steel panel. Because just like on a jet's fuselage, almost no two pieces are the same.
And right there, that was the central conflict of the whole project. The outside of the building demanded this wild, freeform sculptural shape, but the inside, the concert hall itself, needed perfect, predictable acoustics, which, usually means clean lines and simple, boxy geometry. The engineers had to somehow make these two polar opposite needs live together in one building. But in solving that huge structural challenge, they kind of missed something. Something pretty crucial about how the building would interact with its surroundings. This quote from a local resident really says it all. Yep, they accidentally created a death ray. The highly polished, curved steel facade acted like a giant mirror, focusing the sun's rays onto nearby buildings with incredible intensity. It was literally melting plastic trash cans and superheating the sidewalks. They had to go back and sandblast certain panels to dull the reflection. A pretty expensive fix, and a great reminder that physics will always win. So, staying in LA, our final structure, the Broad Museum, solved a really fundamental problem for art galleries. How do you get that beautiful, diffuse, natural light into the space while also protecting priceless works of art from that very same light? And the answer was this absolutely ingenious concept they called the veil and the vault. You can think of it as basically two buildings in one. In the middle, you have the vault, a massive concrete strong box that protects all the art and storage. And then, wrapped around the outside, you have the veil, this light, honeycomb-like skin that filters the daylight.
So you've got this incredible contrast going on. On one hand, you have the vault, heavy, solid, protective concrete. And on the other, you have the veil, light, porous, made from fiberglass reinforced concrete, designed to let light through. They have completely different jobs, different materials, and look totally different, but they have to work together as a single, elegant system.
And the result, the consequence here, is just stunning. During the day, the veil filters light in. But at night, when the lights come on inside the museum, the whole thing transforms. Light shines out through the porous veil, turning the entire building into this luminous city lantern, practically broadcasting the art within to the whole neighborhood.
So, when you look back at these three completely different structures, a really clear theme starts to emerge. The most groundbreaking, innovative engineering so often happens because it's forced to respond to a truly audacious, almost impossible, artistic vision.
So let's just recap real quick. For the vessel, the core problem was that dynamic load and the crazy assembly, solved with precision prefabrication. For the Disney Hall, it was those impossible curves clashing with acoustics, solved with aerospace software. And for the Broad, it was all about controlling light, which they solved with that brilliant veil and vault system.
So what this all really tells us is, first, that visionary architecture pushes engineering to incredible new heights. Second, the real story isn't just how these buildings look, it's understanding why they had to be built that way. And finally, as we've definitely seen, every single one of these bold design choices has real-world consequences, some planned and some not so much. Which really leaves us with a final thought to chew on. What truly defines our modern skyline? Is it just the raw ability to make an impossible shape stand up without falling over? Or is it the more subtle, sophisticated engineering that's required to manage how we, as people, and even how light itself, interact with those incredible forms once they're built? Definitely something to think about.
If you've stayed with us this far, then you already know. Those 3 buildings aren't just construction projects. They are bold expressions of human ambition in engineering and architecture, where form, function, structure, and human experience come together as one.
Today, in this video, we explored 3 of the strangest and most extraordinary structures in the United States. And in the next video, we're traveling to Spain to discover 3 unusual architectural wonders over there.
What do you think? Are the structures in the US stranger, or does Spain take the crown? Watch our next video and decide for yourself.
This content was created by the YouTube channel Constructive Minds. If you enjoy deep and fascinating videos about construction and remarkable engineering works, make sure to subscribe to our channel, hit the notification bell so you never miss what's coming next. And if you found this video valuable, share it with your fellow engineers, architects, or anyone passionate about building the future.